Okay, so today we're going to start videos on the last section of this particular chapter on vectors. We're going to start talking about defining what dot product is. Dot product is kind of a cool operation that you've never really seen before. I kind of like it. So the dot product has an operator symbol, just simply looks like a dot. Okay, so algebraically, if I dot product two vectors u and v, okay, we're going to let u be the vector in component form a to b, and then let v be c to d in component form. If I want to find the dot product, I'm going to write it out like this. And then it is a combination of multiplication and addition. So you're going to multiply the two horizontal vectors, or horizontal components, a and c. And then you're going to add to the product of the vertical components b and d. Okay, and then you get a single numerical answer or a scalar. Okay, so you're going to get a number rather than a vector. Okay, now let's try a dot product problem. So let's find a couple of dot products. So let's say I have the vector -10, 5, and I want to dot product that with 2, -3. Okay, and then we're going to get -10 times a 2 plus 5 times a -3. So we get -20 plus -15. My answer is -35. Okay, let's try another one. Okay, let's have our first vector be 3, -10, our second vector be 7 and -1/2. So we're going to go 3 times 7 plus -10 times a -1/2. So that would be 21 plus +5, because negative times negative is positive. So my answer is 26. Okay, things to note: dot product is commutative. So what that means is, as I can dot product u and v, and it'd be the same answer as v times u. Okay, and we can prove that. Okay, so a times c plus b times d, c times a plus d times b, and since multiplication and addition are commutative themselves, I can prove that dot product itself is commutative. Okay, so what is this used for? Okay, so it's used for a couple of things. Okay, first thing that we find is dot product will tell us about the angle between the two vectors. Okay, so it turns out that A dot B, okay, being two vectors, is equal to the magnitude of A times the magnitude of B times the cosine of theta, okay, where theta is the angle between the vectors A and B. Okay, now the theta that we're going to get is always going to be between 0 and pi. Okay, now knowing what theta is and knowing what the dot product is can tell us how large theta will be. Now, this is just finding the dot product. It's not using the formula to actually solve for theta, but it does give us an indication about the size of the angle. Okay, so if I find the dot product, u dot v, okay, and it's positive, or excuse me, is 0, then that implies, or okay, then that means, sorry, I lost my place. Then theta is equal to pi over 2, okay, or 90 degrees. Okay, if u dot v is equal to the magnitudes, okay, and it's positive, then theta is 0. Okay, if u dot v is just positive, then theta is acute, or less than 90. Okay, if u dot v is negative, then theta is obtuse. Which is greater than 90. Okay, now here's another one that's a little strange. If u dot v is equal to the negative of the product of the magnitudes, okay, then theta is equal to pi or 180 degrees. Okay, so let's try that out. Okay, Okay, so there are my two vectors. So I want to figure out if I can say something about the angle between and then actually find the angle between. Okay, so we need to find two things. Okay, we need to find the dot product, and then we need to find magnitude. All right. So if I do dot product, I get 3 times -2 plus 5 times 13, -6 plus 65, 59. Okay, so it's looking like, okay, my u dot v is positive, so we're probably looking at acute angles, or if it does turn out to be equal to the product of the magnitudes, we're looking at a 0-degree angle. So let's go ahead and find some magnitudes. Okay, magnitude of A, 3 squared plus 5 squared. So that's 9 plus 25, 34. I can probably tell you right now that it's going to be acute. So it's going to be less than 90, but not 0. Okay, so if I were to multiply this magnitude by this magnitude, okay, I'm not going to get positive 59. Okay, so I'm guessing that theta is not equal to 0, but less than 90. Okay, so let's see. Here's my formula. Okay, so I have all my values that I need. So 59 square root 34 times the square root of 173 cosine theta. Okay, now you can go ahead and multiply 34 by 173 inside the radicals. That's fine. They're both inside the radicals. So if I do that, I get a really kind of large number. Okay, so now I'm going to use division. Okay, so I have this. Now we're going to use our calculators using the cosine inverse. Would it help if I typed it in right? All right. So my calculator gives me a value of 40.865 degrees. Okay, and again, my guess was correct. Okay, now, in addition to this lovely formula allowing us to find the angle between our two vectors, we got another word. Okay, and you're going to hear this word in your Edgenuity notes, and that is the word orthogonal. Okay, so this would be some new vocabulary. Okay, all right. So if your vectors are orthogonal, that simply means that the angle between is 90 degrees. Okay? Usually you hear orthogonal associated with vectors. It's simply another way of saying perpendicular. Okay? We know that vectors are perpendicular when the dot product is 0. Okay? All right. So this will be our first video, and then we're going to cover work and projections in the next video.